Hello, my name is Gatóo. I'm a PhD candidate in the Center for Natural Material Innovation at the University of Cambridge. And today I'm going to talk about how kerfing, a cutting method that can kerf or fold wood, can have a role in developing flexible spaces for housing. And I will show this through a pavilion that the Center for Natural Material Innovation, together with PLP Architecture and DUCTA, designed and built for the London Design Biennale this year. But before I start, I want to briefly introduce the Center for Natural Material Innovation, which is based at the Department of Architecture in the University of Cambridge and is directed by Dr. Michael Ramage. It is a cross-disciplinary center that brings together people and research from plant science, biochemistry, chemistry, physics, engineering, and architecture. And we aim to transform the way we build to achieve zero carbon emissions, looking at all scales. With the climate emergency we are facing, where the construction sector accounts for 39% of the global CO2 emissions, with a housing crisis where the global building stock is expected to double by 2060, and with a health crisis that is making us rethink the way we live towards a more adaptable and flexible future, there is an urgent need to rethink the way in which we build our cities. In first place, we need to shift towards natural materials such as engineered timber. And why engineered timber? Well, because it is a natural material that we can grow, a structural material that we can grow. It has excellent structural properties and stores carbon in its cells. But also it can reduce construction time, emissions, weight of buildings, cost, transport, and even it has been proved to create a more relaxed and sociable urban experience. And as I mentioned, we need to create interior spaces that are more flexible and adaptable. So we started looking into flexible partitions for affordable housing in London, based on the London plan to create spatial efficient designs with soft flexibility. Soft flexibility means that the designer doesn't decide on the spatial configurations of a space, but the inhabitant does. We are therefore looking into ways of designing flexible partitions that can be placed anywhere within a space and designed with engineered timber that can be rolled or folded and can be fabricated digitally. So we then started looking into kerfing. We studied and tested to break 6 different patterns, all of them linear patterns, which can just be folded in one direction. And the test showed that many parameters influence the flexibility of a material, such as the scale, the density, the length, the shape, or the orientation, but also the thickness of the material. The graph to the right shows the flexibility of the 6 patterns at a same scale, varying on the length of the pattern. For testing the samples, we fabricated a testing rig that you can see on the left side, and we started developing some foldable models. We then were invited by the London Design Biennale to design a pavilion under the sustainability and innovation theme. We wanted to design a folded structure that was fractal and inspired by the herringbone pattern. So we started with paper models until we arrived to a structure that we liked. We then scaled up into MDF with laser cutter. We choose a linear pattern, the straight lattice pattern, as it proved to be the most homogeneous of all, since all the distances are constant, and so it doesn't create any stress points. We decided that the pavilion should be composed of 6 structures and started modeling them at scale with MDF. The vertices were open to release stress, and through an iterative process of designing and fabrication, we found the optimal size of those openings, but also the optimal size of the parameter, the scale, the length of line, the distance between lines, and the width of the lines. And once the MDF was working, we scaled into plywood. We then fabricated one of the trees at full scale with a CNC machine to study its behavior. The envelope of all the trees was made with 6mm ply, the base with 80mm plies, and it was supported with a CLT underneath to provide weight and stability. The final pavilion took 10 days of fabrication and was flat packed and sent to Somerset House. And this is the final result. We wanted to resemble a walk through the forest so people could experience how engineered timber with digital tools can bring nature back to our cities and how well it feels to be inside a timber structure. As you can see, there are large pattern elements at the bottom and lighter at the top, which resembles also the structure of the trees and the fractal pattern they have. When you fold a sheet of paper, you improve its structural stability and its structural properties. So you make it stiffer and stronger, and the same is true for timber. The main goal of these explorations is to develop new tools and methodologies that can help us replace conventional structural materials with natural ones. Thank you very much.